This is Ed Robinson of Kensington College talking about Grasshopper, in particular Grasshopper scripting. Why would we need to have scripting within Grasshopper? Well, when Grasshopper can do things perfectly well, C# allows us to do things repetitively. Well, so does Grasshopper in a way, but let's see what we mean. I have here an example. If we want to produce this elaborate triangle, what we do basically is take the triangle and then divide it up into a midpoint here, midpoint here, midpoint here, and then draw another triangle. And then we do the same with that triangle. So we take this line of the triangle, we take the midpoint there, the midpoint there, the midpoint there, and then draw another triangle. So it's a repetitive, it's almost a recursive, it's not quite recursive, but it's a repetitive process that's best done using a script. So now here is the Grasshopper setup for it. I don't expect you to understand this, I'm just trying to give an overview of where we're headed. And it's a Grasshopper where we have a C# component here with a script to produce a script. And indeed, here is the script itself. And now, once again, I don't expect you to understand any of this, but just to show you generally where we're headed. So what we've got here, if you look very carefully here, that says divide up that line in half, so that get that point there. And then you do the same thing. Now, how do you do the same thing with each side? We use what we call a for loop. This thing goes round and round. So in other words, it repeats itself. It first finds this point here, this point here, this point here. Then it does it itself on that line. So it repeats it. It takes midpoint of this line, etc., as I showed you before, and then joins them up. Now, once again, I don't expect you to understand, but just get the general idea of why you would use scripting. The answer is when it's a repetitive process. So I'm going to close all this and start from the very beginning. This is asking me if I want to save the actual Rhino, which I'm in at the moment. So I'll close that. I don't want to really save the Rhino, I want to save the Grasshopper. Okay, so we start from the very beginning. Here's our Rhino, so we double click on this here to start Rhino. And from within Rhino, we're going to start Grasshopper. Now, there are a couple of ways of doing that, starting Grasshopper. From Rhino, so when Rhino starts, we can type up here and type in here Grasshopper. There we go. And then if I now just press enter, that should start Grasshopper. But there's another couple of ways of doing that. You can actually set some configurations up here to make sure that it starts automatically. I can show you to do that later. The other thing that I have done, I've actually got a little macro here to start up Grasshopper, a little toolbar thing. But I prefer it to start up automatically, which I've configured. But anyway, we've got Grasshopper started up. Then we want to place a C# component. Well, we want to go from the, let's look up here, it says maths, and then in here is our C# script. So we can click on that and then just produce one of these. And now we could have started a new document as well, file new document, but it seems to work okay just to plonk it on there straight away. Right, now this is our C# component, which will enable us to produce script. I'll straight away just double click on this. Now you have to be careful where you double click on this thing, it does different things. So double click pretty well on this thing here, and that produces a C# script. That more or less sort of belongs to that. You can have more than one of these on here, and that will produce its associate with another, its own C# script. So let's take a look at this script, run script. This is where we do all the work in here, our programming, as we'll see. And if we want to produce some subs, what we call functions or subs really, then little bits of program in here which are called from the main part of the program here. So let's make a simple program. It wouldn't be a programming course without printing out hello world. So what I'm going to do is to use this output here. It's like an output to the screen in normal programming, if you know what I mean. So I'm going to put a panel on here. Now a panel is where you can put some text, and we can just join that up to that. And I've actually written this program before, so it's producing that, which is not very helpful. But Sorry about that. So what I'll do is just show you how I did it. I put in here print hello world. Notice the inverted commas and the parentheses, and whenever you have a print statement, it will be printed to the output up here. Now the way to run the program is to click up here. See that green triangle will run it and produce hello world. What I'll do is get rid of it. So what I'll do is just delete the text there and make that a blank. Now if I run it, it will produce nothing. Now I hope that wasn't confusing, because let me see what I should have done in the first place. I should have started from here. I should have just typed in here print hello world and then run the program, and that's what you can do, and just run it, and it says there hello world. Actually I think there ought to be, by tradition, I think there ought to be a exclamation mark there, so I'll just edit that, and then you can see the exclamation mark appearing. So this is like basic normal C# programming, where you've got an output. Instead of your console application screen, you've got something here you can get your output into. By the way, to get the panel where we got from here previously, what we could have done is to double click on the canvas and type the word panel, and that should bring up the panel. Then you can just click on this and produce a panel. The other very helpful thing is that if you actually click on a component of any description and hold the Control and then the Alt key down and then click on it, it shows you very blatantly where the panel is. But that's extremely helpful. It's very hard to find these little things sometimes. So if I do Control Alt and Delete and click on that, it brings up the C#. That's very, very useful. Now what we're going to do is to try and introduce the coordinates of this point into this C# component, and what we need is a component here which is a point component up the top left in the params. So I'll click that and then place our point component on the screen. Now we need to therefore connect this point up to this point, shall we say, interface into the C# program. So I'm going to very carefully, it depends where we click on this thing. So I'm going to click onto the body of the PT. Don't right click, I should say. So I'm going to right click, and you'll notice this menu is available. But if I make an error and I right click on this, it won't produce what I'm looking for. So we click on the body of the PT, and set one point is what we're after. So that's what we'll do. I'll click on that once, and then the whole thing disappears. If it's disconcerting, it'll come back. If I click on the point, then that has introduced the point. So it's a two-click operation, which is pretty good. Now, by the way, I can just delete this thing here by clicking on it once and pressing the delete key. Is the best way to delete things. Now I need to introduce this point into the C# component, and what I can do is simply connect it. And now I need to go to the C# component and change the nature of this X input. Now that corresponds, you see, to the script, which is this X here will correspond to this X here. Now this is a point, and it's going to have X, Y, and Z components, which we're going to look at. So I don't really like the name of X at the moment. We're dealing with X, Y, and Z for that particular point. So I'm going to change the name of this input. So I'm going to click on it, and here it is here, you see. I can change it. And how about P for point? Sounds good to me. But there's something else that we need to do as well, and that is to go to the type hint. I don't know why it's a hint, but it's what it's supposed to be, and it's 0.3D, which I've just previously set it to. So you need to click on that to accept 0.3D. Now when we do that, first of all, if I click away, you'll notice that it's changed to P. This is not being used at all, but it corresponds obviously to this Y in here. Now at the moment it says object X over here. Now what I want it to be is a point. We've set it to a point, sorry, but hello, it doesn't appear there. So let's just close this, and if I open it again, the C# script, by clicking here in the middle, by double clicking, you'll notice now that it's been changed. The input type has been changed to 0.3D. Okay, so now we can refer to that point P in code. If I type P, now watch this. If I put a dot here, these are all the methods and properties that are available to us. Now, for example, the one that we want for the moment is just the X component. But look at the others. For example, you can have the distance to another point and so on. So I'm just going to put in the X component is what I'm looking for. And then I'm going to print it. So I'm just type in front of that, print, and then open. Now, there's a little bit of a problem here because this thing here, it's going to have the value of 10, which indeed is what we call a double. And print doesn't like doubles, it likes strings. So we have to a little bit convert that to string. Change the value of the double into a string being a piece of text, of course. So now, if I now run this, it should print out the value of the X component. So now in order to run it, of course, I click on this little triangle at the top here, and that should produce the value, the X value, which is 10. Well, that's great. We're on a roll here. So let's print out the Y and the Z values as well. Let's copy that and then print that down, and I'll just change. I'm very particular about my indenting, and I'll just change that to Y here and this one to Z, and that should print out the 3 components of that point. 10, 10, 0, which is great. Notice I've got the grid snap turned on down here, so it means that it's exactly, when I put the point on there originally, it's exactly 10 and not 9.9. There are a couple of ways that we can introduce that point into our program. I'll just show you another way of doing it. I'm going to actually delete that point here. Now, once I delete, if you click there, notice that I'll just press the delete key and notice that there's nothing available at the moment. Now, the way to do it, another way to introduce a point is to right click on here on the point and then manage point collection, and then we can make a point here by clicking this and then edit those values, and I'll just put in 5, 5 and then 0 and then click OK, and you'll notice it's produced my point at 550 but it's not appearing here. So let me just run the code by clicking the little green triangle at the top, and when we run it, we pick up, now it's also picked up by the look of it, a reference point as well as our point 550. Let me just see what's going on here. If I go back to look at the values, manage the point collection, it's got a reference point in here. It seems that's uneditable, and it looks as if that needs that will always appear. And of course you notice that our point has appeared as a red cross this time. So what I'll do, I'll just delete that. Well, it looks like we need to clear the values from here. Okay, so now let's start again and try another technique of producing a point, the third one. So we'll create our own point in code this time, and the way we do that is using this bit of code, point3d. Now this is the type we call this. It's a point type, and that's the name of the object. In fact, this is a class, what we call, and it produces this object of this class, and we're producing a new object, and this is what we call a constructor. Actually, it produces a new point with these coordinates 10, 10, 0. So we're making our own point in code. Now I won't send the output to out at the moment. I'm going to therefore comment this out. Now the way to do that, by the way, is Control K and then followed by Control C. We'll comment the whole thing out. What I want to do though is, rather than to send the output to the panel, I'm going to send the output to the canvas. So, and we should have our point appear on the canvas. Now let's try. Now the way to do that is to take, here you see is the output. Now this is like the graphical output, if you like, which is going to appear on, and it's very simple. All we need to do is to say A equals to the point, which is P1, with a semicolon, of course, and then we run that, and an error point should appear at 10.10.0. If we want to stop the code, by the way, we turn the preview off. So what we do is to highlight all of the code and then right click and find the preview, which is here, and just say preview off, and that basically stops the code from running. Incidentally, if we make a mistake in our code by just doing something silly and then try to run the code, then it brings up an error message in our output. The type name POI can't be found, and so on. And you can see the error message will appear in here, this little red thing, which is very convenient. And this whole thing, if you click in the canvas, this C# component will go very red. So then you need to just go back and fix up your error. I'll do a Control Z actually to undo the error, and then run it, and that error message should then disappear. There's nothing to stop us having the data appear in the output panel as well, and to do that I'll just comment that Control C, Control K, Control U will undo the commenting, and that's now P1. Now, by the way, it's different from this P here. That's got nothing to do with what we're doing at the moment. It's a new point that we've constructed. I'll just type in here P1, and then when I run that, you'll get the output into this output panel as well.